afternoon. So I'm Varuni, and today I'll be giving a lightning talk on the topic, building the first Grapheme-Aware Tokenizer for Kannada, keeping our languages alive in the AI era. A little bit about myself. I work as an STE at Couchbase. I was at JP Morgan before that. I love distributed systems, graphs, and NLP. And I'm also an independent researcher, and I've published papers at some very cool conferences like MIT URTC, AAAI, and IACTC. OK, so before I begin, I want to give some motivation of why I chose this topic and why I chose to work towards this topic and research on it. A few months ago, all the AI companies were coming out with really good LLMs, right? ChatGPT came out with GPT-5, Gemini 3, Grok, all of these. And their selling point was they were releasing benchmarks on top of benchmarks, telling how good they were at reasoning tasks and how they beat the IMO gold medalists and all of that. So I thought of a simple experiment. So all of these benchmarks were in English. All these questions were in English. So I thought, what if the same question, you give it to the LLM in any other language, right? So what I did was I took one of the questions from IMO 2024, and I gave it to GPT and Gemini, but in 2 different languages. So the first one that I did was Kannada. This is a variation of the philosopher's question, if I'm sure all of you know about that. So something interesting happened. This is Gemini. With Kannada, when I give the same question in Kannada, it gave me the wrong answer, which is n square minus n. But the same question in English gave me the correct answer. Similarly, an algebra question in Hindi gives me the wrong answer, but in English gave me the right answer. This was ChatGPT. So this points to a bigger issue, right? This is research which came out last month, which spoke about how badly all of these LLMs, be it open source or closed source, perform when it comes to Indic languages. They measured it for 11 Indic languages. And if you can see, none of the LLMs even get accuracy of above 45%. And this is a data set which had around 13,000 questions, which was multi-choice questions based on language reasoning, logical reasoning, and general knowledge. So none of the LLMs passed the accuracy of 45%, whereas for English, they were giving an accuracy of about 85 to 90%. And this is not just an issue which is theoretical, right? This trickles down into our AI applications, and it becomes a big problem. This was, speaking of the real-life impacts, I don't know how many of you remember, but this was an issue where in July 2025, the CM posted a tweet on Facebook and Instagram expressing his condolence for an actress who has passed away. But when Meta's auto-translation AI picked it up, it translated Kannada into English. And the way that it translated into the fact that the CM had passed away. And this was like a big fake news. And Karnataka actually asked Meta to take down the auto-translator until this issue was fixed. So these are the real effects of the accuracy drop that you see, in the models. But why does this happen? This is because the design was thought out for LLMs, English was the center of these languages. They were not designed for any other languages which is not Latin script-based. So the first step that you see is tokenization there, right after data collection and preprocessing. This is the first step that happens, or that any LLM has to go through in the LLM trailing pipeline. So what is tokenization? Tokenization is, like I mentioned, the first step in any NLP pipeline, where you take the text and break it down into small units called tokens. And then they are mapped to numeric IDs, because machines only understand numbers, right? So this allows them to understand and process our language. You can think of tokens as the smallest unit that a language model can understand. Just like atoms are the building blocks of our universe, tokens you can understand as the building blocks of an LLM's understanding of a language. Just to give you an example, so let's say we have a sentence that is tokenizing, and if you split it character-based, then you split it by alphabet. You can also tokenize based on a word level or a subword level. Tokenizers do a mix of everything, or only one thing. So now you might be thinking, why does tokenization matter? And tokenization matters because it is the first step in the training process of an LLM. And the tokenization part decides what an LLM sees and how a language is represented. It also has an effect on the memory usage and context length, training tasks, and downstream performance like speech recognition or language translation. So if you look at the picture on the right, you can see something interesting. So this is the stats from a few of the tokenizers which are widely used, that is word piece, sentence piece, and BPE. And for English, you can see that the fertility score is 1, which means that there's a one-on-one based mapping for the character and the token. So every character, every subunit will take only one token. But when you see for other languages, so there's Hindi, Bengali, Tamil, etc., you can see that the scores go up, right? 3.2, 4.1, 3.9. And this means that just to represent one unit, now the LLM will require 3.2 to 4x more tokens. And this is not just some disadvantage, it's actually a structural problem. A good tokenizer would compact meaning, keep the tokens consistent, therefore you will have better language modeling. But a bad tokenizer, when it fragments the meaning, there are inconsistent tokens, and this leads to drop in accuracy and model confusion. Now the question, why is it that English-centric tokenizers, where do they fall short? And this is because Indic languages and most Asian languages, they belong to the Abudiga family of scripts. So the script is different. And our characters, they are not one-to-one mapped with the Unicode points. So for example, if you take an example of Kannada, a single character like kru, it has a lot of characters in it, right? There's a consonant, there is a halant, there is a vowel sign. And when, let's say, a BPE tokenizer tokenizes it, it tokenizes it like this, where it splits it into meaningless characters. But what we want the LLM to understand, and what we as humans understand, we as speakers understand, is kru, which is the meaningful token, right? But the problem is the LLM doesn't see this. It reads kru as this 4 to 5 split meaning pieces, which is why it's hard for it to understand the language. So what we're getting at here is that it's not that the LLMs are bad at reasoning in these languages. It's just that they don't understand the grammar and the script itself. And this is because of a failure to the tokenization process. So this is an example for Hindi, where Asvi, Karan, Yata is the word, and BPE splits it into a few characters. Word piece, it adds hashes, which is basically the markers, which again would add noise to the model, right? Because there is no word like this in Hindi, but that is how word piece would split it. It's because of a prefix, postfix mapping that it has, but it does not work for Hindi. And sentence piece, it does it into subwords, but if you see clearly, karya is a word, but it is not a character. And that is where it fails to, it might get some of the grammar right, but it will not get the full vocabulary properly. And the bigger picture that we see here is that the AI system is not seeing the language at all, it is seeing noise. And when this happens in literally the very first step of LLM training, that noise just snowballs. And then you get issues like wrong translations or failure in OCR and all of that. So all of this might have seemed like theory to you, but then the effect is not theoretical at all. It is very real. So for example, because of the higher number of tokens that are required to represent these Indic languages, or any non-Latin script for that matter, the first effect that you have is higher API and inference costs. And this is because users will have to pay more for the same amount of content that you need to generate in, let's say, Telugu, as opposed to you would want to generate in English. So you are paying more just for the same amount of content. And you have reduced context windows. Let's say you need to, process maybe 10 pages of a script which is in Kannada. Maybe the model will not be able to fit it into the context length because the tokenization takes up a lot of the tokens compared to English. And this is a very big problem because we have a lot of all the government documents, for example, are in the regional languages. And when you have these disadvantages when it comes to AI, it becomes very difficult to adopt AI for India. And degraded model performance because of the fragmented tokens, and the models don't really understand the semantic meaning of the words. And all of this leads to linguistic marginalization. Because if AI performs poorly for Indian languages, people will slowly start shifting towards English and for all of the tasks, right? And because of this, the language will start to weaken, and the next generation, which grows up on the internet, maybe they won't even see the language. So to mitigate this issue, which happens in the tokenization process, I built something called Grapheme-Aware Tokenizer, which takes into account the natural word boundaries and the semantic meaning of the language and respects the grammar of the language. So it's called GAT, Grapheme-Aware Tokenizer. So it has mainly two components. First is a custom Unicode normalizer. This is because, again, Unicode was built keeping English in mind. So Indic Unicode sequences, the same character sometimes will have different variations of Unicode points, multiple different ways in which you can represent that in Unicode. And this, again, is variation which would lead to like noise, which is why first we have a normalizer which would fix these inconsistencies. And this was built for Kannada, can be adopted for any language, which is from the Abudiga family. Next, you have a rule-based grapheme parser, which parses the text into true orthographic syllables, which is the aksharas. And then you run it through BP, which is like the normal tokenization pipeline. And on the right side, this might look very complex, but it's actually very intuitive. If you think about it, the way this was built was how a human would read these languages, right? So first, you have a consonant. We pick that up. Next, you have a vowel. We attach that. And if a halanta comes, we know that a consonant is coming, so we join that. And if it's a diacritic or a sign, we merge it into the same unit. So you maintain a list, and until you get the proper akshara, you keep appending it to the list. And then when you get the akshara, you move on to the next vowel. So that is the while loop in short. This tokenizer is open source at Hugging Face, so all of you can check it out. Next, I have a small demo to show you how, just to give you an example of how this would work. So yeah, so you can see that the Kannada word is hoguತ್ತಿದ್ದೇನೆ, and this is the characters that you see, which don't really make sense, which the tokenizers now split it into. But the way that this GAT would work is it would accumulate these and split it like this. Can you reset it and run it again? Yeah, so ho, then you have gu, then you have ti, and de, and ne. So this way, when you split it into, when you respect the word boundaries of the language and you split it into proper aksharas instead of seeing meaningless fragments like that, the model will understand proper representation of the language, because this is when we write it, this is how we write it, and we don't really write it like that, right? And when you properly make sure that the LLM understands the representation of your language, all the downstream tasks from there become better. So your accuracy becomes better. You have less tokens that you need to use to represent the language, which is why it will reduce your inference costs and make it better from there. So this is the results. This tokenizer was trained on 4.5 million Kannada sentences from the Samantara and the Kannada Instruct dataset. These two are the only available datasets for Kannada as of right now. And we compared it against the most commonly used tokenizers today, which is sentence piece, word piece, and BPE, across vocabulary sizes. Vocabulary size essentially means the variety of characters in a language that an LLM can recognize. And if you can see the results here, CR means compression ratio. It is how well the tokenizer is able to compress the language. So higher is better. Fertility score is how many less tokens a tokenizer uses to represent one word. So that is lower is better. And speed is, of course, like the speed in which it will convert. And you can see that across all vocabulary sizes, GAT performs pretty well. So for 8K, it's 3.5, for 16K, 3.9, and for 32K, it's 4.8. And the speed is around 1.15 million characters per second, which is pretty good, and it beats all of the existing tokenizers. So yeah, with that, I want to conclude my lightning talk. The reason that I wanted to give this talk was less about the tokenizer and more about a call for action. Because if it is true that LLMs are the future and AI is the future, and a lot of our communication, the way we communicate and the way we learn, LLM is always in the pipeline, then we need to make sure that all of our languages have equal space and they're represented equally. And India has around 122 major languages and thousands of dialects, right? And we need to make sure that they don't die in the AI era. We need tools, data sets, and tokenizers which are built for our language. And we should not treat all these adapting for these languages for LLMs as an afterthought, like it has been done right now. A lot of the work for languages that these companies are doing are in the post-training phase, which does not really help. It's just like patchwork. We need to make sure that they're included in the design and in the pipeline. And I wanted to conclude with the beautiful words of Grace Hopper herself. The most dangerous phrase in the language is, we've always done it this way. Yeah. Thank you.